Welcome and hello. This is a video lesson on the HEC RAS controller. In this lesson, I'm going to describe how to run a simulation. This is a very important step in most HEC RAS controller scripts, so I figured I'd dedicate a separate video for this particular topic. In this lesson, I'll provide a VBA script that opens a HEC RAS project, runs a simulation using the HEC RAS controller object. Right, so what I have on the screen here is a very simple 1D RAS model. I'm going to first run the model manually, and then we'll look at the results, or at least the resulting files from the computation, and then we'll perform the same task using the HEC RAS controller. So right now, here is the project directory. I don't have any results or any output files. What you're seeing here is quite simply the project file, .prj, plan file, that's .p, the geometry file, that's .g, and then the flow file right here, this is the unsteady flow file, .u. I will leave a link to this web page right here. This is from the HEC RAS User's Manual. It describes which file extensions are for which type of files. So at the top we have .prj is the project file, .p is the plan file, .g right here, this is for the geometry file. You're probably already somewhat familiar with these different files if you've used HEC RAS to any extent. But anyway, I'll just go ahead and leave that link to that page in the description. Also in this directory, I just have my two different Excel files that I'm using for the VBA script. Not part of HEC RAS per se, but I just wanted to keep these files with my other project files. So these are the only files we have so far. When I run the compute for this HEC RAS model, we're going to get a number of output related files, .o files. We're going to see the output.dss file. We'll see some .hdf files. Let's just go ahead and run it. So I'm going to come up to run and then unsteady flow analysis. All of my settings are good to go. So I will manually click on compute, run the simulation. This should only take a couple seconds. Okay, and then that is completed. Here is the project directory. Now we have a bunch more files. So now we have a .o04 file. That's the output file. A little o04. There's an HDF file. There's a .x01 file. I'm not going to talk about what all these files are, but basically, we also have a directory here for our plan, which was called scenario 1. Inside that, I've got a .hdf file. So anyway, these are the resulting output files we should expect to see in our project directory after computing our HEC RAS model using the HEC RAS controller. So I'm going to go ahead and close this, and now we should have some results. So I could click on cross section and then view the different water surface elevations, and all the other results should be available to us. So I'm going to just delete all those files that were generated during the compute. A quick way to find the most recently created files is to just sort by date modified. And that was at 906, so everything with a 906 in it. Yep, I think up to here would be good. All right, so this is the same starting files as before. All right, very cool. All right, so let's go ahead and head over to Microsoft Excel. I have a file here called controller.xlsm. And then if you don't already have the developer tab, add that in. Click on the developer tab, click Visual Basic, go up to Tools, References, make sure you have HEC River Analysis System selected as one of your references. Click OK. All of that is described in more detail in Lesson 1. I'm going to start by going up to Insert and then Module, and then double click the module. So I'm writing my VBA script right here in my Module 1. And then I'm going to paste in the code here to run compute. This is as simple as I could make it, basically. The subroutine is called compute. And what it's going to do is open the project, and then it's going to run the compute, and then it's going to close the project. So we've already seen this before, opening the project. We're first going to create a HEC RAS controller object called on, and then we're going to use that to open up the project. I have this commented out, show RAS. We don't have to show RAS, but so I'm just going to leave it commented out for now. And then further down here, let's actually show the computation window first. This particular function is going to actually perform the computation. It's called compute underscore current plan. And then there's a number of parameters after that. We'll talk about those. And then finally, I'm going to display whether or not the computation was successful in a little message box pop-up. So typically I'll use the console window, but sometimes I'll use a message box pop-up window. So it'll display compute successful, and hopefully it'll say true for this compute success variable. We'll click OK, and then the last step of the script is to close the project. All right, so a little bit more detail on the compute here. These are our parameters, which I have right here. It is message count, messages, and blocking. Scroll back over. Message count, this is a long integer. It's going to be the number of messages returned from that function. Messages, the array, this is a string, the second parameter. This is a string array for the message text. And then blocking is the third parameter. This is actually an optional parameter. So what that means is if blocking is set to true, and true is the default behavior, so if you don't even set it, it will be true. That basically means the script will pause during the computation. If it's set to false, which it would have to be set to false explicitly, then it would not. So just think of synchronous versus asynchronous. I think the safest behavior is to just wait, set it to true, or again, leaving it blank and not including this third parameter at all would be the safest, but maybe a little bit slower. But if any of your subsequent processes in your script rely on the output from that compute, then you would definitely want blocking to be set to true. So let's go ahead and see if that works. I'm also going to bring up the project directory here just kind of as a proof to see if new files are created after we run the script. And since this script is opening up the project itself, I'm going to go back to RAS and save it and close it. Okay, so that should be good to go. I'll just click on compute here and then run subroutine user form. Okay, so it's opening up. This is the same window that we see when we're running the computation manually, and it looks like it's done. So I'll click on close, and sure enough, here, oh yeah, multiple things. Here is our dialog box to tell us that compute successful is true. That's a good sign. And then here is the project directory, and we have the same output files, the HDF file, the .o file, the project.dss file we would expect to see if we were successfully running the simulation in HEC RAS manually. The one other line I commented out right here is going to hide that computation dialog box because we saw it pop up and then we were kind of forced to close it. If you want to not even see that dialog box pop up, you can include this line and it says compute underscore hide computation window. In fact, let's do that, but let's also not close HEC RAS at the end. So that's good. I'll go ahead and reset and then save. So this is ready to run again. But before I do, I want to again delete the files in the project directory so I can have another visual confirmation that they've been created. Now, granted, I could compare date time, date modified values, but it's a lot easier to just see the difference between 6 files versus 20. So here is the directory for the plan. And then right here are all the files that were created when we ran the compute. So I think we're good to go there. Let's go back to VBA and then click on run. So it should be running. Again, we're suppressing that computation window. Here are the files that are being added, the DSS file, the output file, and then eventually we're going to get, I think it already popped up. So here it is, compute successful equals true. And HEC RAS should still be open. Okay, it's not. Maybe I commented this out after saving it last, so no big deal there. But I could now open up my HEC RAS, view the results. I could use the output results in the files, the output file and the .dss file for future computations. All right, well, that was it for this lesson. What we talked about was running a simulation using the HEC RAS controller.